In this video, I will be done an application using mediapipe that starts with a boilerplate code to detect hand gestures and then adding upon it some enhancement to actually move custom object created using three.js moves following the hand. So this is the repo where all the changes are committed and all the changes were done in stages into these different branches. Step 1 contains the initial boilerplate code which has a single webcam window where using mediapipe we are detecting the hand. Then step 2, step 3 till step 10 adds on small features, the details of which could be found in the readme. For example, step 1 was initial change with the webcam window, and this also had the media pipe integration. So this is the initial boilerplate code need to start and just its detection using the webcam. Next branch is Torus following hand step 2. This had added second webcam window and Torus. Torus is a 3.js object that we added to the scene, the second webcam window, and it is moving following the hand, but this is uncalibrated. In this commit, I have calibrated the position of torus. In the next one, the size and the pixel ratio and added the light source. These things are getting added. These are three.js changes. Then in this branch, I added a rotation to the torus. So every new frame, the torus rotates. Then in this one, I added multiple toruses. In this one, I removed the original torus and added rotation for the multiple toruses that I added in this one. Then added movement of torus with the buffering. So this movement you will see that this will be not as smooth. So in this branch I've added buffering logic so it appears a smooth movement. Then this one made the trailing toruses smaller. So multiple toruses that are added, all are of different sizes. The first one is the biggest one, then the smaller, then smaller, like that. The last one, there is a feature called shader material which is shown here. So not here. In this tab, shader material is a three.js class which lets you write custom code to create the material. It uses the GLSL. This is OpenGL and this directly runs on the GPU. So let's start with the demo first. Go back to the browser. So here I am running the final version which contains that shader, this thing that I showed. The shader material, which is the custom one, but we'll start with the first demo, and for that I have a shell pat script here. Switch branches, what it is doing, it is switching across all these branches that I showed and staying in each branch for 10 seconds so that we'll be able to see the demo. So let me start that, run /switch. Okay, so this is the first branch. This is the boilerplate code where just detecting hand using the media pipe library. In this one, torus has been added, but this is not properly calibrated. The hand is moving differently and the torus is moving differently. This third branch, here the torus is moving with my hand. It is calibrated, but you can see the color is not that much proper and it's showing blurry. So after adding a light source and some another pixel in modifications, this is how the actual torus appears, follows the hand. In next one, added a rotation, so along with moving, torus is rotating in its place. This one. In the next one, I added more toruses, but those are static. The original one is still rotating. In the next branch, I removed that original one and instead moving all these new toruses with my hand. In the next, now these all are following, but it is following with a distance. Okay. In this one, the buffering logic has been added, so the movement looks smooth. This is the final one using the shader material. It's exactly same as the previous one, just that the material has changed. Now let's go to the code so we can, the main now. I have added these diff commands that you can check to compare two branches. So starting with step 2, we can see, or before that, let me go to the first branch. So I will do git checkout. This is step 1. So this is the boilerplate code where we have some basic CSS, some div elements, a canvas, a video, gets the camera source. This is how camera is added. A stream is returned. Video elements are source object is set to the stream. This is started, play, and this is hand detection logic. This is all the boilerplate code from mediapipe. These two dependencies are added. And then on results, it is drawing those connectors that we see. Okay, moving on to the diff between these two branches, step 1 and step 2. It bigger. So you can see in this one there is a additional div added, that is our second screen. This also has the similar changes where the same stream is set to this video element in the second one, and then this is played. This is the three.js section where camera and other materials are added. Camera, geometry material, and the torus object. In this one, this was the one that was not calibrated, so you can see I'm getting the XYZ directly based on this middle fingers X, Y, and Z. So these coordinate, these XYZ, and the coordinate in which the three.js object gets created, they are not calibrated, so they cannot be set equally. That's why when we set these, we were seeing calibration issues. Let's move to the next one. This one was calibrated, step 2 versus step 3. So if I compare these two, you can see instead of setting XYZ as it is, there is some offset being set and some scaling being done. With that, it is calibrated, and like how we saw the movement. Next set of branches are the step 3 and 4. So here, uh, we remember there was a scene where the doors were appearing black. It was because there was no light source. So these light source were added, pixel ratios were changed, and there was some blurry also. Those gets fixed by this one, and the light, the color that came, that gets fixed by this one. Moving on to next branch, this is 4 versus 5. And this one, the rotation is added, just minor change. Towards rotation dot axis added 0.05 every next frame. Similarly, the Y, this is 5 and 6. Similarly, let me go on to the last one. It's 9 versus 10. So this is in 9 versus 10. You can see I have commented out this mesh standard material and instead calling this create advanced material. This create advanced material is the one which is creating 3.shader material that we saw the documentation. It provides these variable vertex shader and fragment shader, and this entirely is WebGL code that runs on the GPU. This can be seen, some similar syntax can be seen in here. See, it talks about this vertex shader and the fragment shader. So yeah, that's it for this video. Just trying to keep it under 10 minutes. Thanks for watching.